on YouTube? All right, let's not do that, please. All right, so we are going to do section R5 now. So let's put that in there. So it's R5. We're going to, again, break this up. This book, the sections are really big. It's not, I mean, I guess it's designed as a high school book. I don't know what they thought, but the sections are bigger than your normal math book that you've had up to this point. Usually you can get through one section in a class period. Up to this point, anyway, they've been pretty long. So we'll just call this R5, and we'll probably have 3 sections again on this one. So just be aware of that. So what we've done so far is we have multiplied polynomials together. We're going to do a thing called factor. So let me just run through something real quick here. So let's say you had the number 30, okay, and I wanted you to find the factors of 30. So, for instance, if I said 2 times 3, I'm going to go way back in time. 2 times 3 is 6. We have a certain name that we call the answer to a multiplication problem. What do we call that? It's not the sum. It's called the product. Okay, it's called the product. Now, these two things that are being multiplied together to get the answer, which is the product, the two things that are being multiplied together are called I just said it, the factors. Okay, so, oops, my pen's acting weird. Factors. I haven't used it in a couple days. Maybe that's why. I don't know. All right, so that word says factors, F-A-C-T-O-R-S. It's kind of weird looking. I think when I write real small, it doesn't work so well. But anyway, they're called the factors. So if I took the number 30, all right, let's just take this number right here, and let's put it right here in the middle. And I want to break it up into its prime factors. Well, what's prime? Do you know what the prime numbers are? It would be 2. 4 is not prime. A prime number is a number that can only be gotten by multiplying, let's say, a prime number is, right, you can only multiply 1 and itself. Okay, so for instance, like 2, is 2 prime? Yeah, because it's only 2 times 1. Is 3 prime? Yeah, because it's only 3. No, it's not. No. Every number is not prime. Listen, got some talking. 2 is prime, 3 is prime, because only 3 times 1 is 3. What about 4? Is 4 prime? No. 4 times 1 is 4, but is that the only thing that multiplies together to get 4? No, it's 2 times 2, so that's not prime. Is 5 prime? Yes. Is 6? By the way, is any even number except for 2 prime? No, because it's always 2 times something, right? So you can forget all the even numbers. You with me on that? Okay, 7. Is 7 prime? Yes. Is 9 prime? No, because 3 times 3 is 9. Is 13 prime? Is 17 prime? Is 18 prime? No, because it's even. 2 times whatever. Everybody got it? 27. Is 27 prime? No, because why? 3 times 9. Everybody got it? That's primes. So let's talk about this number right here. Let's break this up into its primes. Do you remember when you were a kid, you did this kind of stuff? Oh, there goes my pen again. I must have clicked something. Hold on. Even numbers are not prime. They're not just odd numbers, because 27 is not prime, but it's an odd number. Do you remember you did this factor tree back in the day? So you went 3 times 10. Okay, but are they the prime factors of 30? No, because 10 is not prime, is it? So I drop that 3 down, and I break 10 down some more. So what is that? 2 times 5. I'm going a little bit in a weird direction, and we don't really have to know this to do what we're going to do today, but it does talk about factors, okay? And that's what we're going to do today. We're going to talk about factors. So what are all the factors of 30? Well, 2 times 3 times 5. They're all the prime factors of 30. What we're going to do is we are going to find the factors of polynomials. For instance, let's see where I want to start. I'll tell you what, let's do another thing. This is kind of review from what we've done already. Okay, and if I was to multiply those two things together, can you do that in your head? It's FOIL method, right? So what's your first one? X squared plus what? Outside, inside. So what's the outside going to be? 3x. What's the inside going to be? 2x. Add those together, you get 5x. And then the last term is 2 times 3, which is 6. Would you agree? This right here is my product. See, we just went from basic arithmetic, now we're in algebra, okay? And what do you think these two things are? These are your factors. Okay? So what we're going to do today, we are going to take this, and then we're going to come up with what the factors are. Okay? So I'm going to give you something that looks like this, and you have to tell me what times something is equal to this thing I'm going to give you. Okay, so here's what the problem would say if I gave you something like this. I would tell you to factor, and a lot of times we'll say completely. I just won't write that on there. Factor completely, but x squared plus 5x plus 6. And what you're going to have to do is you're going to have to give me what two things multiply together to get this. Well, you see it already. So what two things multiply to get this thing right here? I got it up here already. We started with it, right? X plus 2 and x plus 3. I'm not even going to show you today how to go from here to here. All right? Well, another day, probably tomorrow. Okay, I'll show you how to do that. But today we're going to do some special kind of factoring. Okay, some special, I think they call them special products or something like that. I don't know. Do they call it? Anybody have their book open? These are going to be special, I don't know, we'll just call it factors. I think they may call it special products, but we're just going to call them special factors. So these are ones that I'm going to show you what they look like. Hopefully we'll recognize what they look like, and we're going to be able to factor fairly easily. So let's do some, before we do some real special ones, let's do a common factor, all right? A common factor. So if I ask you to factor, I'm going to write down a whole bunch of things, okay? So here's the first one we're going to do. If I ask you to factor 2x plus 4, what you want to look at is look at both of those terms. Do they have anything in common? So the first kind of factoring we're going to do is common factors, okay? If you want to write that down, you can, okay? But this is common factors. Is there anything in common? Is there anything being multiplied? I should say this. Is there the same thing being multiplied by this and by something to get to this? 2, right. 2 is being multiplied by x to get to 2x, and 2 is being multiplied by what to get to 4? 2, all right? So what we're going to do, sometimes I'll say this. We'll pull it out. We'll factor it out. We'll divide it out. Okay, those are words I might use kind of interchangeably, all right? So we're going to factor it out. So what I want to do is basically I'm dividing everything by 2 is what I'm doing here, okay? So if I take this and pull out a 2, factor out a 2, divide out a 2, what am I left with? I'm just x. And then if I divide this by a 2, I have a 2. Now you could always check it, couldn't you? You could always multiply this and to see if we end up with this thing. And it works. This was the easiest one. You did this in pre-algebra, right? Algebra 1 at least, okay? 2x plus 4 is 2x plus 4. Absolutely, okay? Let's do one a little bit longer. I'm going to skip a couple of these in the book because I want to get to some good stuff. But this is important. How to factor a common factor is really, really important. In fact, when you factor stuff, you should always look for this first. You should always look for a common factor. Okay? So right here, I got 2x squared, 4x, 8. Is there anything in common? Is there a common factor with all three of these? Not a 4 because 4 doesn't divide into 2 evenly. Okay? A 2 does though, right? Same thing. It's not always going to be a 2. It just happens to be that way on here. If I pull out a 2, if I factor out a 2, what am I left with? X squared minus 2x plus 4. Because I just took every one of these terms and I divided it by 2 is all I did. All right, stuck it out in front. Would you agree that these two things are equal to each other? Yeah, absolutely. All right, you've done this before. This isn't new. Am I right on that? Yeah. Let's do, I'm going to skip to the last example for common factors. There's some other examples in there. If you want to look at the book at some point, you can do that. but I think this is good enough. Now, let's see what's in common with both of these terms. I got a 6x squared and a 9x. Is there anything that divides, or what's the largest thing, that common factor? Well, yes, there's a 3 that divides into 6 and a 3 divides into 9. So definitely a 3. Now, is there something that divides into x squared and x? Yeah, there's an x in both of them, isn't there? Okay, so we're going to pull out, okay, or divide out, factor out a 3 and an x. Put a parentheses because this is multiplication. We want to find out what multiplies to be this right here. So really it's a division problem now, isn't it? To figure out what goes in here. It's 6 divided by 3, which is 2. X squared divided by x, which is just x. Put the plus sign there and do the same thing here. So we're dividing, we're factoring out the 3x from the 9x. So 9 divided by 3 is 3. X divided by x is, it's not 0. What's x divided by x? It's 1. Okay, it's 1. So it's 3 times 1, which is just what? 3. And that's it. That's your answer right there. I should circle these. I'll circle this one. All right, that's factoring. That's a common factor. All right, now let's do some of the special ones. All right, is it quarter of? Is that when we're out of here? Yep. Okay. 45 for those who don't know the old version of it's telling time. I said that last year, and like, what are you saying, Mr. Hamrick? I said quarter of. You know what that means? No, it means, Peyton, you're looking like you don't know what that means. A quarter of an hour. It's okay. I thought you were looking at me like what's he talking about? But that's the look that I got last year. All right, let's do a couple of these. I'm going to write these names down because I'm going to refer to these quite often. The first one is the difference. Let's listen now. Okay, you can discuss the time thing later. Let's talk about this right now. This is called the difference of two squares. Write that down. It's important that you know the name. The difference of two squares. I'm going to give you a very general. This works for any numbers. All right. This is very, very general. This is kind of like your formula, I guess, if you want to call it that. So first of all, difference. What is the difference? What in here makes me see difference? The subtraction. Okay, the subtraction is the difference. Okay, between the difference of two squares. Look, are there two things that are being squared here? Yeah, you're squaring the x and you're what? Squaring the a. Everybody got that? So this is something you should look at and you should recognize that this is a difference of two squares. Let me show you how to do this. First thing we do is we set up two sets of parentheses. Okay? Difference of two squares, one's always going to be positive in the middle and one's always going to be negative. That's how I do this. When I recognize, everybody's up here, right? Yep. Apparently not. So one's going to be plus, one's going to be minus. And then watch what you do. It's very, very simple. Put an x first, put an a second. If you can remember that little, it's not really a trick, but it's a little formula. That's the difference of two squares. They don't give you, don't yell out things, please. Okay, if you have a question, raise your hand. Okay, yes. Where does the squared part go in? I'm going to show you. Well, let's just do this. Let's go backwards. What if we were going to multiply this? What if we were going to take this thing right here? This should equal this. Would you agree? Yeah. All right, so let's see if it actually does. So it's FOIL method. So x times x is x squared. Outside is negative xa or ax, however you want to write it. The inside is what? Plus ax. You see that? Yeah. Then the last is positive times negative is negative. A times a is a squared. Is this the same as this? No. Yes, it is. Because negative ax plus ax does what? Okay, it adds up to 0, technically. You could say cancel out. That's okay. But it adds up to 0. So really, what is this? This is x squared minus a squared. So do you agree that this little formula right here works? Yeah, absolutely. So there's your little formula. Get rid of all that stuff. There's your formula right there. All right, and it works. Okay, so that's difference of two squares. Let's do another kind. So that's one of our special ones. These are ones that you should look at and try to recognize at first. Okay, the next one is called a perfect square. Yeah, these are all these we're doing today are all special ones. Yep. All right, so let's do a perfect square. So if I had x plus a squared, that's what we consider a perfect square. Okay, this is really what we would do when we factor it. This is kind of like the answer. I'm going to show you what the question would be. So if they give you something like this, well, I tell you what, let's do this. Let's work it out. X plus a in parentheses squared. Do you remember what we do here? Put them both in parentheses. Remember, you can't just say x squared plus a squared. Make sure you don't do that. We warned about that the other day because there's no distributive property for exponents. You cannot distribute the square. So what we're going to do here is we're going to put x plus a. So what do you do when you square something? You multiply it by what? Itself. All right. So let's go through the math and see what it actually comes out to be. So it's FOIL method. Let's do it quick. X squared plus ax plus ax. What's plus ax plus ax? Plus 2ax. Okay? You're adding. Okay? It's ax plus ax. Okay? You don't add the exponents when it's a plus sign. All right? When it's addition. Okay? If I have one ax over here and I got another ax, how many ax's do I have? I got two of them. All right? And let's do the last thing. It's a times a, and a times a is a squared. So this right here is equal to this. But what we want to do is we want to recognize this little formula right here. We want to recognize this. So what does it look like? I got something that's squared on the one side. I got a different thing that's being squared over here on the other side. And then what do I do to get the middle? I just take the x and the a and I just double it, or I multiply it by 2. Does that make sense? So if I had this, if I had x plus 3 in parentheses and squared, what would that be? That would be x squared. What do? We take the outside, it's x squared. What do we do with the two inside ones? Well, you multiply and then double it, right? Because they're the same thing. Because it's really FOIL method. It's first, outside, inside, last. The outside and the inside are the same thing, right? Right? Because if I have x plus 3 times x plus 3, I would have a 3x plus a 3x. And what would that give you? A 6x. Plus a what? What do we do with this? 3 squared, which is 9. So this and this, it works perfectly. But what we're going to do is this. Hold on just a second. What we are going to do is this. I'm going to give you this thing right here. And what am I going to say in front of it? I am going to say to factor. All right. Now, we didn't quite get to the end of it. I'll just assign it tomorrow. Okay. So no homework tonight. I'll just assign it tomorrow. So if you look at RenWeb, we're going to be about half a day behind. Okay. So if you look at RenWeb, it's going to be off a little bit. So I'll just assign it because we just didn't have time today. All right.